Okay, so today's lesson is going to be on finding slope and the y-intercept. Now we're going to be doing this from a table or a chart, as you would say, and then we're also going to be doing this from a graph. So our two essential questions are, how do I find slope and the y-intercept on a table? And then we're going to look at how do I find slope and the y-intercept on a graph. So let's get into it. To find the slope from a table, the function first must be linear. So we only can do slope if we have a linear graph or function or table chart. It's got to be linear. If not, then it's not constant. So we don't have a constant rate of change, which is another term for slope. So the first thing we need to make sure is that we have a linear function. And then we did equations already for slope. One of them that we did was y2 minus y1 over x2 minus x1. And these two other equations are probably familiar. They mean the same exact thing. So for slope, we could use 1, 2, or 3, any three of these. This one you've probably seen in physics before with the delta y over delta x. Remember, delta means change of, so the change of y over the change of x, which is exactly what we calculate when we do rise over run, and exactly what we calculate here. So this is basically this version, just a little bit written out more. So the change in y over the change in x. Okay, the y-intercept is where the function crosses the y-axis, and also known as when x equals 0, so that will be easy to spot on our graph and on our table. So here's our first problem right here. I want you to find the slope given this table and the y-intercept given this table. So I don't care which method you want to set up. I just did change in y over change in x. So first let's look at the change here. Let's see, is it constant? Is it going up by the same every time? So from -4 to 4. -4 plus or minus what is 0? Okay, -4 plus 4 gets me up to 0. 0 plus what is 4? That's plus 4. 4 plus 4 is 8. 8 plus 4 is 12. So we have a constant rate of change of adding 4 on the left-hand side. So let's check our rate on the other side, and we're going to see, is it going up by a constant rate of change, meaning the same rate of change? So we have to think, what is this going up by? Now, negative numbers you might not like too much, but if we look down here, 0, 2, 4, this is going up by 2s. Plus 2, plus 2, plus 2. So let's check that pattern. -4 plus 2, yep, that is -2. So that works. -2 plus 2 gets me to 0. So now we want to write this in slope form, so rise over run. And now I always say write this down first because you want to make sure you put the right number on top. So my y number, my change in y, it is going up by 2s. So I have to put the 2 on top, and the 4 has to go on bottom. From here, I see that I can divide a 2 out of both of those. So this reduces to 1/2. So the slope here is 1/2. Up 1 over 2, up 1 over 2, up 1 over 2 is the slope of this table right here. So if I graphed it, that's what it's going to look like. The y-intercept, now for the y-intercept, I already gave you a hint earlier. You're going to look to see when x is 0. So here I have the x, and it's 0. So right here, this coordinate point is my y-intercept, and I'll show you why. So first of all, we write down y-intercepts as a coordinate point. So this is over 0, down 2. So if I were to graph that over 0, down 2, left and right 0, but down 2, here's my y-intercept. Notice that it crosses my y-axis. And then my slope, so if I were to graph this, it'd be up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. And that's where I would get these coordinate points from. Okay, let's try a second one. Okay, so right here, We're going to do the same thing, change in y over change of x. So we are looking for the pattern. What is it going upright on this left-hand side? -10, -5, 0, 5, 10. Again, it might be easier to tell the pattern in the positive numbers, but we are going up by 5 on the left-hand side. And then over here on the right, what am I going up by? Well, I'm actually not going up. 10, 7, 4, 1. These numbers are going down, so I need to see what am I going down by. 10 minus what is 7? 7 minus what is 4? Oh, this is easy to see. 4 minus what is 1? That is a -3. So double check that pattern. 10 minus 3 is 7. Yep. 7 minus 3 is 4. 4 minus 3 is 1. 1 minus 3 is a -2. So let's stack this on top. Make sure I put my y's on top. I've got -3 over 5. And both of these numbers are prime numbers. You cannot reduce. My slope is -3, 5. And my y-intercept, remember I'm looking when x is 0. My y-intercept is at 4. So again, you have to write it as a coordinate point, 0, 4. So if I graph this, it'd be left and right 0, and then down 4. So there's my y-intercept. And then this is a negative slope, so I'd be going, if I was going to graph this, I'd go down 3, 1, 2, 3 over 5. Down 3 over 5. So this is actually going to go down because this is a negative slope. Okay, let's take a look on the next page. Now, what I'd like for you to do is go ahead and pause the video, and I want you to try these two on your own. Yes, actually pause the video and try them on your own. Just do it in pencil so you can erase it if you have any mistakes. Okay, so you should have seen some interesting things happen here. My y-intercept on the left was at 0, 0, so that is actually the x and y-intercept. They cross both at the origin. And then you should see an interesting thing happen here. So it was going up 3, and then up 1, up 1. And so at first I would say, well, that's not linear. But then it had the same pattern on the right. Up 6, up 6, then up 2 and up 2. And here's why this is still a linear pattern. So if I go with the first two values, rise 6, run 3, 6 over 3, I can reduce that. If I divide a 3 out, pull a 3 out from both of those, that's 2 over 1, which is exactly what we get over here. So it is still indeed a linear pattern, and my slope is 2. On the right-hand side, this looks a little bit different. If the x value is always 2, and then here are my y values, so I actually plotted this so you could see what it looks like. This is a perfectly straight up and down, so we have a vertical line. And so if I think rise over run, it's rising some number, but it's never running any number. So it's just staying at 2. There's no change. Plus 0, plus 0, plus 0, plus 0. So it doesn't matter what number you change over here. You're always changing 0 on the bottom. And what happens when you type that in a calculator? What happens when you do 1 divided by 0? Does anyone know what you get? You're going to get an error. Divide by 0 error. You cannot divide by 0. So what we say, this has a special term. We say that the slope is, the word is undefined. Slope is undefined on that. Okay, so I'm going to show you another example of that in just a second. So let's go down to finding slope and y-intercept on a graph. Okay, so when we are finding slope and y-intercept on a graph, there's a few things that we've got to do. We are going to be counting the rise and run. So we want to pull out all of the good points, is what I like to call them, on the graph, where they cross a grid mark perfectly on a grid, and we are going to count the rise over run, rise over run, rise over run, rise over run, rise over run. So from here to there, it is going up 2 and then over 1. So my slope, which if you remember from last year, we also can use the variable m. My slope is up 2 and over 1. So my slope is 2 over 1. And then my y-intercept, where it crosses the y-axis, is right here. So that coordinate point is 0, 4. Over here on the right-hand side, again, we have an interesting line right here. So let's look at our slope, my rise and my run. So if I count the distance between these 2 points that I have given you, I am rising up nothing, but I'm going over 10. Now, 0 divided by 10, can I do that, or will I get an error? 0 divided by 10. Okay, that is 0. So my slope here is 0. So you can say the slope is 0, or you can say there is no slope. Both of those work. No slope or 0. And then my y-intercept right here is at 5, so 0, 5. Okay, moving down here, we've got, now this one is going down 2. So I'm going to put a -2 there. Down 2, but forwards 1, so that's a positive 1. Down 2, forwards 1. Down 2, forwards 1. Down 2, forwards 1. So my slope is a -2 over 1. My y-intercept is right here at 5, so that's 0, 5. Last graph over here to the right, if I write my slope, m equals, so my rise over run, so let's say I go from my lowest point to my highest point. I am rising up 4, 1, 2, 3, 4, and I'm going over 0. And we get the same issue. 4 divided by 0 can't work. You can't divide by 0. So we use our fancy word again. We say the slope is undefined. So if I ask you what the slope is, you're going to say undefined slope. That's going to be your answer. You cannot give a number. And then also, y-intercept, does this ever cross the y-axis? Never crosses it. So there is also no y-intercept. So, undefined slope and there's no y-intercept. Now let me show you something that maybe you've seen before, maybe you have not, but here is a little shortcut to remember these two special cases when I have a horizontal line and I have a vertical line. Maybe you've heard this phrase before. It's called hoy-vux. I know it sounds kind of weird, but H stands for a horizontal line, so here's my horizontal line. That means that the slope is 0. And if I were to write the equation of this line right here, it would be y equals 5. So the equation of the line starts with y equals, and then you put your number. Vux down here is for a vertical line, a straight up and down line. So for a vertical line, we say that the slope is undefined. That's what the U is for, undefined slope. And then if I were to write the equation of this line, right where it crosses the x-axis at 3, so the equation of this line would be x equals 3. So x equals. So hoy-vux, I would write this on the side of your page and keep this so you can use that to help you remember our special horizontal and vertical lines.